All right. Hello and welcome to my channel. I am Professor O and I'm doing a live stream for math tutoring. So if you're out there and you need help with your math, you can post problems in the chat and I'll work them for you on the board. Happy Tuesday. I hope everyone's doing well. And yeah, I'm just going to go ahead and get into it. I am working on systems of linear equations. And right now I'm using matrices to solve the systems. And so that's kind of the game that I'm going to be doing tonight. So yeah, I'm just going to get into it. And reflecting from yesterday, I can't believe I forgot my linear algebra book in the other room. I solved this system really fast and I didn't anticipate that. So I've come prepared. I got my book and I'm just going to pick another system out. And again, working towards trying to solve one with 4 variable. I think we're going to do one more in 3 variable. So I picked this system out of my textbook, and it's just the next problem after the one I already did. So didn't really search far and wide for this problem. It's just we're still in chapter 1 of this linear algebra textbook. So again, I'm just practicing. I'm working on my board, and if somebody's watching and they want to give me a problem to work, that would be exciting. So go ahead and start this one. We've got, let's see, x plus y plus 3z, and that equals 3. No, that equals 6. And x plus 2y plus 4z equal 9. And we're at 2x plus y plus 6z, and that equals 11. And I just want to double check the numbers real fast to make sure. X plus y plus 3z equals 6. X plus 2y plus 4z equal 9. And 2x plus y plus 6z equal 11. Perfect. All right, so I've got the problem worked out, and we'll just see how it goes. So I have this system, and it looks like I've got the 3 variables, and so I'm going to set up my matrix, and this is the Gauss-Jordan method. This is called Gauss-Jordan Elimination. Well, you know what? And this is just me trying to learn how to write and organize on the board. We'll go ahead and this heading has been up there for a while, and it's been a while since I've written a heading, so we'll just say Gauss-Jordan. And working on my board and hanging out, doing some math, and trying to not be too stressed about it, which can be challenging, especially for me. I'm camera shy, so it is what it is. So, all right. So I'm going to set up my 3x3 matrix here and just get all my coefficients. So we've got 1, 1, 3, 1, 2, 4, and 2, 1, 6. And then I'm going to list my constants, and it's going to end up with a 3x4 matrix. I've got 6, 9, and 11. There we go. All right. And so the method begins. And what we're going to be doing is we're going to be solving the system by what we want to do is we want to turn this 3x3 matrix into the identity matrix, and whatever's left over will be the solution to my system. And so what I'm looking for are, they're called as elementary row operations. And what I'm trying to do is I'm trying to use a combination of those three main row operations where I can swap rows, add rows, or multiply rows by scalars in any order. And that's kind of the gist of it. So what I'm doing is I'm trying to find the fastest method of solving this without the use of tools. So I'm just using my own brain and a little bit of experience. So if there's anyone out there that wants to help me solve this system, they're more than welcome to do it. That'd be awesome. So you give me a first step and then I can do it at any point. So I'll just be watching to see my chat, to see if anybody wants to help out. All right. Audience participation is encouraged. All right. So what I want to do is I want to come up with the best. There's many options I have. Any first step would work, but I want to try to solve it in as least amount of steps as possible, ideally trying to fit this on my board, honestly. So I just want to take my time, look at the system, and see if I can come up with it. All right. I think what I'll do first is try to get my zeros here. So let's go ahead and multiply. Let's multiply row 3 by a -1 and add it to row 1. So I'll say negative row 3 plus row 1, and we'll replace row 1. So what I'm going to do is I'm going to go ahead and write in my second column because it's going to be untouched. So 1, 2, 4, 9. I'm going to go ahead and perform this multiplication here. And so that'll be -2, -1, -6, and -11. And then I'm going to take my new value and add it to my row 1 and see what happens. So this will be -2 plus 1 will be -1. -1 plus 1 is 0. -6 plus 3 is -3. And I have -11 plus 6 is -5. All right, so I have 1 0 established. All right. And so what do I want to do next? I don't want to get in too big of a hurry because, I might miss something. So, all right, I could make another 0 really fast if I added these two and replaced it with row 2. So let's do that. Let's say row 1 plus row 2, and we'll replace row 2. And we'll do that one here. So I'm going to go ahead and we're replacing row 2, so I can just put in -1, 0, -3, -5. And I'm going to add these rows and replace that with row 2. So -1 plus 1 is 0. And 0 plus 2 is 2. And 3, negative 3 plus 4 is 1. And negative 5 plus 9 is 4. And then we'll just add this one in here. Negative 2, negative 1, negative 6, negative 11. I remember years ago when I was taking linear algebra, and I asked if there was, well, I wanted to know, I was curious if there were any, like, rules of thumb in solving these, like any shortcuts or anything to keep in mind, and I was told no. But over the years, I've found that if you find the zeros in your column and your rows first, then it makes it a little bit easier. Right? So I think that there are things that come with experience, but these things just take time. They take experience. So I like to find my zeros first. And then I can kind of move them around a little bit. All right, so let's see what else we can do. I can make this one 1 by adding these two, but I don't want to get rid of 0. So what I'll do is, if I do that, I'll go ahead and replace it with row 3. So let's do that. Let's add row 2 plus row 3 and replace row 3 this time. And see what happens. So I've got negative 1, 0, negative 3, negative 5. And we're adding row 1 and 2. We're going to replace row 3 so we can add row 2 in here. 0, 2, 1, 4. And then we can add them in one place. So we have 0 plus negative 2 is negative 2. 2 minus 1 is 1. 1 minus 6 is negative 5. And 4 minus 11 is negative 7. See if that doesn't help. Okay. Just think about it for a minute again. We'll stop and pause. So what I'm thinking right off the bat is to go ahead and multiply row 1 by a negative 2, and then I could add it to row 3, and then I will probably replace row 3 if I do that. I guess we can do that. So I don't see anything else to do. So we'll say negative 2 times that row. So negative 2 row 1 plus row 3, replace row 3. Put that in here. We got negative 2 times 1 is 2. Negative 2 times 0 is 0. Negative 2 times negative 3 is positive 6. Negative 2 times negative 1 is 10. Positive 10. We're not touching row 2, so we'll just copy that in here. And then we're going to add that to row 3. So we've got 2 minus 2 is 0. 0 plus 1 is 1. 6 plus a negative 5 is 1. And we got 10 plus a negative 7 is 3. Right. I'm trying to write these matrices a little bit smaller so that I can not use up so much of my board. And just get this one over with. 5, 4, negative 7. A bit better. -5, 4, -11. Okay. All right, see what else we can do next. So I probably want to multiply row 3 by a -1 now, because that's going to turn both of these numbers into 0. This will be a 1 and this one will be a 0. So we'll replace, let's replace row 3 again. So we'll say negative row 3 plus row 2, replace row 3. See what happens. All right, so I'm going to go ahead and copy the first two rows. We have 2, 0, 6, 10. And I have this one 0, 2, 1, 4. And then I'm going to multiply this by a negative. So we have 0, -1, -1, -3. And then I want to add that. We have 2, 0, 6, 10, 0, 2, 1, 4. Now let's add them. 0 plus 0 is 0. 2 minus 1 is 1. 1 minus 1 is 0. And 4 minus 3 is 1. This one is solved. So that's the middle row. So we want to swap those out eventually. And then I need this number right here to be 0. So I'm going to multiply let me rewrite it. Let me just rewrite this, just swapping out these two rows. 2, 0, 6, 10, 0, 1, 0, 4, and 0, 2, 1, 4. I just swapped out the rows. So maybe I should go ahead and multiply row 3 by a -6. And add it to row 1. So -6 row 3 plus row 1. Let's see. That'll be, and we want to replace. All right, so we're going to add it and replace row 3, I guess. And I don't have room here, so we'll have to scoot it over and do it here. So, all right, so we're going to go ahead and copy both those two down. 2, 0, 6, 10, and 0, 1, 0, 4. And then we're going to multiply 3 times 6, so we get 0, -12, -6, and 6 times 4 is -24. And then I'm going to add row 1 and row 3. And we'll replace row 3. You know, that one will be 0. That would be 2. Yeah, we'll replace row 3. So, let's see. 2, 0, 6, 10, 0, 1, 0, 4. And then adding those two, you've got 2. Either way, there's a 0 on it. to 2. All right, never mind. I don't want to do that. I'm going to back up. I changed my mind. Here, let's back up and look at it again. All right, so instead of multiplying that by 6, I'm going to go ahead and switch these columns out like I did 4. All right, and rather than doing that, I don't want to turn this 0. If I add these two, row 1 and row 2, and I replace row 3, then I've eliminated that 0. So let's go ahead and try to make one of these 0 first. And the only way I can do that is multiplying this row by a -2 and adding to row 3. So we'll say -2 row 2 plus row 3 replace row 3 and see what that does. I'm going to try and fit it in here because I need to start saving them. So we've got 2, 0, 6, 10. And then multiplying this, we've got, see, 0, -2, 0, -8. And then adding this row to this row 3 and replacing row 3 is going to give me 0 plus 0 is 0. 2 plus 2 is 0. 0 plus 1 is 1. And -8 plus 4 is -4. Let me see what I got now. Perfect. So it looks like the only one I have to get rid of now is the 6. So what I'm going to do is I'm now going to multiply row 3 by 6. So I'll say -6 row 3 plus row 1 replace row 1. So let's see if that works. So we're not going to type in, we're not going to write in row 1 because we're going to replace that one. So we'll start with writing in row 2. 0, -2, 0, -8. Go ahead and perform this math. So these are both going to be 0. And then -6 times 1 is -6. -6 times -4 is positive 24. Wait. Is it negative? Yeah, negative. Okay. And now I need to add those two together. So it's row 2 plus row 3. Wait a second. It's right here. It's -6 row 3 plus row 1. All right. So it's this one plus this one is 2. 0 plus 0 is 0. 6 minus 6 is 0. And 24 plus 10 is 34. All right. And now all I have to do is multiply by the scalars. So we're going to remember the reciprocal. And let's go ahead and see. So I'm going to multiply this by the reciprocal 1/2. This one's going to be multiplied by the reciprocal of -2, which is -1/2. And this one will be multiplied by the reciprocal of -6, which is -1/6. Good. So I've got 1, 0, 0. 34 divided by 2 is at 17. And then we've got 0 and 1, 0, and half of, okay, so -8 times a -1/2. That's just a positive, and that's going to be 8/2, which would be +4. And the same thing here. Got 0, 0, 1. And then you've got 24/1 times -1/6. So that's going to be negative 24/6, which is going to be -4. So here is my solution, x, y, z equal 17, 4, -4. And I did not see the solution in the back, but what we could do is we could check really fast, plugging into the original system. So we've got this ordered pair x, y, z is saying 17, 4, -4. And if we have solved this correctly, then it will satisfy each one of these equations. So let's just try the first one. So we'll just plug in. So we've got 17 plus 4 plus -4. See if that equals 6. That does not equal, wait, oh, it's, thank goodness it's 3. 17 plus 4 plus 3 times -4 is what it is. See if that equals 6. So we got 17 plus 4 minus 12 equals 6. So 17 plus 4 is 21 minus 12. No, it doesn't, equals 9. See, so that first one is not correct. 17 is not correct, I don't think. And then let's check the other ones. Let's see. So we've got 17 plus 2 times 4 plus 4 times -4. Does that equal 9? Let's see if we can get it to equal 9. 17 plus 8 minus 16. 17 minus, that equals 9. This one checks out. 9 equals 9. Maybe I did some weird math. 17 plus 4 is 21. That's 12. Yeah, I knew that was 9. Okay, so the second one works. See if the third one works. We will be close. So we've got 2 times 17 plus 4 plus 6 times -4, and see if that equals 11. So it's 34 plus 4 minus 24. So 34, that's 10 plus 4. 14 does not equal 11. No. Okay, so this one's not equal. So we're close. We're very close. So I don't know which ones are wrong, which ones are not wrong. I don't think I have the solution in the back of the book. And again, solving systems with 3 variables is not the most practical method for matrices. Again, we're just practicing, and it does take a lot of practice. So I really enjoy writing these out and working them. They are challenging. So somewhere in here I made an arithmetic error, and that's the impracticality sometimes using matrices. So you really see the beauty of solving with matrices when you get into like larger systems, like 4 or 5 variable. It's a lot harder to solve those algebraically. So ideally you'd want to use the matrices, but I need the practice, so it's okay. I don't know if I want to scrap the problem or we'll just stop there. So it's 30 minutes in, it's probably a long enough video, and I showed up and I tried my best, so we might just pause this one and it'll give me something to do tomorrow. I'll try to work on it and see if I can find my mistake. One of the beauties of having to work a problem twice is that the second time you work it, you find like shortcuts. So I'll be able to solve it. Let me count my steps real quick. It looks like there's 11 steps in here. And so honestly, I solved in 11. I didn't solve it correctly. Before I leave, I'll go ahead and look in the back and see if this one happens to be in the back. I didn't pick it specifically for it to be in the back, so I don't know if it's there or not. But we can always look. So this one was problem number 10. It's not in there. Okay. It is not, because that is 10D. We've got E in there, so we'll do E next. I should have known. What I guess I can do is we can solve it algebraically kind of pretty fast, I think. Yeah, it's all right. We'll figure it out. This is not correct. We'll cross that out. All right, very good. Anyway, so Gauss-Jordan elimination, and yeah, we can go ahead and stop there. I'll go ahead and sign off and say, yeah, thank you for watching my video. If you need help with your math, please don't hesitate. I will do my best to help you. That's why I'm here. And I will be back same place, same time tomorrow. And I hope everyone has a wonderful rest of their Tuesday. And yeah, I'll just say bye for now, and I will see you next time.